Welcome to part 3. Hope you enjoyed part 1 and part 2. In this part, we are going to be looking at exam question papers, learning how to eliminate theorems which are not on a problem. We are going to be left with theorems which are on a problem together with what we have learned in part 1 to solve that problem. Now, let's get an example on an exam question paper which we need to first eliminate theorems which are not on this particular problem. Now, in the figure, O is the center of the circle. O is the center of the circle. And PT is equals to PR, is equals to PR. So this is equals to that. Let angle R1 to be equals to Y, and angle O1 to be equals to X. Now, 10.1, we are told to express X in terms of Y. But before I can even look at that question there, before I can even express X in terms of Y, I need to first eliminate all the theorems which are not on this problem. Then we are going to be left with the theorems which are on this problem. Then we are going to solve this problem using the theorems which are left and what we have learned in part 1, as we have done when solving problems in part 2. Now, how do we eliminate theorems which are not on this problem? We know that we've got 4 theorems on chord. We've got 2 theorems on cyclic chords, and we've got 3 theorems on tangents. Now, this is how we must first eliminate the theorems. We must ask ourselves if there are chords here. And yes, I can see a chord. There are chords. Are there cyclic chords here? No, there are no cyclic chords. They didn't talk about cyclic chords there. Are there tangents? No tangents which are in this problem. Now, since there are no tangents and there are no cyclic chords, theorems on tangents and cyclic chords are out. Now we can look at the theorems which are on chords. Then we first eliminate all the theorems on chords which are not in this problem. Now, do we have a line from the center to the midpoint of the chord? No, we don't have a line from the center to the midpoint of the chord. Do we have angles at the center 2 times angle at the circumference? Yes. Therefore, theorem number 2 is in this problem. Do we have a diameter here? There's no diameter. Therefore, there's no theorem number 3. Do I have angles at the same segment? I don't have angles at the same segment where they are subtended by the same chord or same arc. No theorems on theorem number 4. So in this problem, we only have theorem number 2 that we are going to use to solve this problem together with what we have learned in part 1. Now, they said to us we must express X in terms of Y. For us to express X in terms of Y, we can say that O1, I know that we are used to naming Q angle OR. At this point, they told us that O1 is Q angle OR. So no need for us to stress ourselves. Therefore, O1 is equals to 2 times angle P1. Angle O1 is equals to 2 times angle P1. Reason for that is that theorem number 2, angle at center is equal to 2 times angle at circumference. Angle at the center is 2 times angle at the circumference. Now, we know that O1 is X equals to 2 angle P1. We can get angle P1. You will see why we must solve for angle PY. I divide by 2 there, by 2 there. What you do in mathematics on the left, you must also do on the right. Angle P1 is equals to x over 2. Now, we know that this angle there, which is P1, is equals to angle R1 plus T. This angle is equals to this plus this. We use what we have learned in part 1 now, because we have used the theorem. Now we use what we have learned in part 1. Exterior angle of a triangle is equals to the sum of the opposite interior angle. Therefore, angle P1 is equals to angle R1 plus angle T. Yes, we are used to say P angle T R to mean T. We are used to P angle RT for our R1. But since we are given R1, since we know that this is T, since we know that this is P1, therefore this angle, which is P1, is equals to angle R1 plus angle T. Reason, we know exterior angle of triangle PRT is equals to sum of opposite interior angles. Now, we know that this is equals to this plus that. We also know that this angle R1 is equals to angle T is equals to angle T, which is equals to Y. We know that. Why is that? Since base angles of isosceles triangle PRT, base angles of the isosceles triangle PRT. Why is it isosceles triangle? Because PR is equals to PT. Now, since angle T is equals to angle R1, so it means that this is Y plus Y. Now, from here we get there, which is angle P1, which is equals to R1, obviously is equals to T, which is equals to that, which we're going to have Y plus Y there. Y plus Y, which is equals to 2Y. But we know that our angle P1 is equals to x over 2. Where we see P1, we put x over 2. Here, we've got x over 2 for P1. Then we know that for P1, we have substituted x over 2, which is equals to R1, it's y, plus T is also y, since we have said that R1 is equals to T, which is equals to y, base angles of an isosceles triangle. Therefore, this is over 1. We can cross multiply. This times this, x is equals to this times that for y. We have expressed x in terms of y. Now 10.2, they say if TQ is equals to TR, if this length is equals to that length, and x is equals to, and x, I'm just going to remove here. Now, since we are told that TQ is equals to TR, TQ is equals to TR, and x is equals to 120 degrees. They say to us, A, calculate the value of y. Now, for us to calculate the value of y, we have just expressed now x in terms of y, where we said x is equals to 4y. Now, since for A we are told to find y, and we know x, then we can substitute 120 is equals to 4y. Then we divide by 4 there, divide by 4, y is equals to 30 degrees. Now, they say B, we must find angle R2. We must find this angle there, R2. Now, for us to find angle R2, we need to construct. We're just going to construct using a red marker. There, it's my line or my chord QR, which is constructed. Now, for me to find this angle here, I need to find this angle there. I know this angle there. I also need to find the whole of this angle there. And for me to find this angle there, I know this angle is equals to that angle, which is 30 degrees. This angle is 30 degrees. Therefore, since this line is equals to this line, it means that this angle there is equals to this angle there. Let's write it down. Q angle RT, Q angle RT is equals to R angle QT. Reason? We know that base angles of isosceles triangle TRQ. Why are they base angles? Because QT is equals to TR. There's my reason that this angle is equals to that angle. Now, I can find this angle here, which is this angle. How do I do that? I'm going to say Q angle RT plus R angle QT plus this angle here, T, which is plus angle T is equals to 180 degrees. Reason? Sum of angles on triangle TQR or RTQ. Now, this is equals to that. Now, if this is equals to that, I can put this here because this is equals to that. So I can put this here. This plus this obviously is going to be 2Q angle RT plus angle T, which is equals to 180 degrees. We must not forget this is 30. Since we've got our y to be 30, we said this angle is equals to this angle. Since this line is equals to that line, this angle is equals to that angle. Therefore, we got that y is 30, so it means that t is 30. 2 angle QR is equals to 180 degrees minus angle T, which is 180 degrees minus 30 degrees, which is 150 degrees, which is equals to 2 angle Q RT. Sorry, this is T there. Angle RT. Divide by 2, divide by 2. This cancels with that. Q angle RT is equals to 75 degrees. Now, let me remove here. Now we got Q angle RT, which is the whole of this angle. Now we can find this angle, which is Q angle RO. Since we know that Q angle RO is equals to R angle QO, reason base angles of isosceles triangle ORQ, because this angle is equal to this angle. Why is that? OQ is equals to OR. We know that these are radii. Base angles of isosceles triangle ORQ, where OQ is equals to OR radii. Now, we know that we can add this plus that to get 180 degrees. Now, Q angle RO plus R angle QO plus Q angle OR equals to 180 degrees. Why is that? I'd like to erase here. We know our reason here, it's sum of angles on triangle ORQ. Now, since this is equals to that, where I see this here, I can put this. So I put this here because they are equal. So this plus this is going to be 2Q angle RO plus Q angle OR equals to 180 degrees. We know that this is 120. We are told that this is 120. Therefore, 2Q angle RO plus 120, which is equals to 180 degrees, which Q angle RO is equal to 180 minus 120, which is 60 degrees. Now we divide. Obviously, we're going to have 2Q angle RO equals to 60 degrees, which I took this, I put it there. I divide by 2, this cancels. Q angle RO is equals to 30 degrees. So Q angle RO, this angle here, is equals to 30 degrees. We know also that this angle here is equals to 30 degrees. Now, we do have this angle, we do have this angle. Now we can find this angle because we do have the whole of this angle. Let's write it down. Can I remove here? Now, it means that we are going to have, Q angle RT. Q angle RT is equals to Q angle RO is equals to Q angle RO plus O angle RP, O angle RP plus P angle RT plus P angle RT. Obviously, this whole of this angle is equals to this angle plus this angle plus this angle. That's what it's equals to. Now, Q angle RO is 30. Q angle RO is 30 degrees plus O angle RP, which is angle R2, what we are looking for. P angle RT, this is not 130. This one represent R1. Therefore, we know that P angle RT, which is Y, or which is R1, which is equals to 30 as well, 30 degrees. But we know Q angle RT, we have found it before that it is 75 degrees. We have found it that it is 75 degrees, if you can remember in the first, when we started with this problem. Therefore, this will be 60 degrees plus angle R2, which is equals to 75 degrees. That side, 75 degrees minus 60 degrees is equals to angle R2. Therefore, R2 is equals to 15 degrees, you can see. Therefore, angle R2 is equals to 15 degrees. As you have seen that I have used theorem number 2, and I also use what I've learned in part 1, where I use sum of angles on a triangle, where I also use sum of angles on a triangle, and I also used exterior angle of a triangle, which we have used that, or we have done that in part 1 together with the theorem 2. Let's look at another example. In the diagram, two circles have a common tangent TAB. So my B is there. In the diagram, two circles have common tangent. So two circles have common tangent TAB. TP or PT and PT is a tangent to the smaller circle. This is a tangent to the smaller circle. You can see that. Now, PAQ and QRT and QRT and NAR are straight lines. Now, they say let angle Q to be equals to X. Let angle Q to be equals to X. Now, they say to us, name with reasons 3 other angles equals to X. Name with reasons 3 other angles equals to X. Now, obviously, before we can dive in a question, we need to eliminate all the theorems which are not in the problem. And in the first example, we have seen how to eliminate theorems which are not on a problem. Now, let's eliminate theorems which are not on this particular problem. The first thing we do, we ask ourselves, are there chords? Yes, there are chords. Are they cyclic chords? They never told us anything about a cyclic chord here, therefore no cyclic chord. Are there tangents? Yes, they are tangents. Now, it means that theorems on cyclic chord are out, So we are left with theorems on chords and tangents. Now let's eliminate all the theorems on chords which are not here. Is there a line from the center to the midpoint of the chord? Theorem number 1. There's no line from the center to the midpoint of the chord. Therefore, theorem number 1 is out. Is there angle at the center 2 times angle at the circumference? No, there's no angle at the center, angle at the circumference. Theorem number 2 is out. Is theorem number 3, is there any diameter? We are never told about any diameter. We can't assume that AQ is a diameter. So we are never told about any diameter. Therefore, theorem number 3 is out. Theorem number 4, angles at the same segment. No angles at the same segment. As you can see, even in this circle, no angles on the same segment. Therefore, theorem number 1, 2, 3, 4 are out on chords. Now, obviously, cyclic chords are out. Do we have theorems on tangents? Yes. Is there theorem number 7, a radius and a tangent? No radius and a tangent. Theorem number 7 out. Is there theorem number 8? Theorem number 8, there are no tangents from the same point. Okay? Probably there are, because you can see this is a common tangent to this and that. Then this is a tangent. Therefore, we do have a tangent. Theorem number 8, T8, is there. Do you have theorem number 9, tan chord theorem? Yes, we do have. Because look at this angle. It is subtended by this chord. And this chord made an angle with this tangent. Therefore, yes, theorem and theorem number 9. So we've got theorem number 8 and theorem number 9 in this problem, together with what we have learned in part 1. Together with what we have learned in part 1, we are going to solve this problem. Now, they say to us they want 3 other angles, name 3 with reasons, 3 other angles equals to x. Now, I can see that A2, angle A2, which is this angle, is equals to angle Q. Reason? Tan chord theorem. Because this chord makes an angle with this tangent, this chord makes an angle with this tangent, therefore this angle is equal to the angle in the alternate segment. Therefore, A2, since we know angle Q is equals to x, therefore A2 is also equals to x. Now, well look, there is this angle here is equals to this angle there. We have an x. You can see there's an x. Therefore, this angle is equals to this angle there. Therefore, A2, angle A2 is equals to angle A5. Is equals to angle A5. Reason? Vertically opposite angles. Vertically opposite angles. Now, A5, we know A2 is x, angle A5. Therefore, another angle which is equals to x is A5. Now, we can find another angle which is equals to x. We can see that this chord makes an angle with this tangent. Therefore, it means that it is equals to this angle in the alternate segment. Or it means that it's equals to this angle which is subtended by the very same chord which makes an angle with the tangent. Therefore, we know that angle A5 is equals to angle P P2 is equal to angle P2. Reason? Our reason, we still say tan chord theorem. Now, we know A5 is x, which is equal to angle P2. So we do have three angles which are equals to x. It's A2, we also have A5, we also have P3, which are equals to x. Now, 8.2, we are told, prove that APTR is a cyclic quad. APTR, APTR, APTR. It's a cyclic quad. And when they say we must prove that, and you can see that P is not on the circumference of any of this circle. So it means that there's another circle, which is a dead circle here. And this circle here, that's where it's here as well, here, here. So it means that you must have an imaginary circle that goes like that. That goes like that. It's a circle. So it means that you must have an imaginary circle where this point, this point, this point, and this point are on that imaginary circle. Yes, it does not look like a circle because this is not drawn to scale. Therefore, it means that they are not saying that you must prove that APTR is a cyclic quad of this circle or this circle. No, it means that once you prove that APTR is a cyclic quad, then it means that there's an imaginary circle there which makes these 4 points to be on the circle. Therefore, once we prove that it's a cyclic quad, then we can think that there's a circle which is imaginary on those points. Now, they say prove that APTR is a cyclic quad, and for us to do that, I'd like to remove here. Now, for us to prove that this APTR is a cyclic quad, we can use exterior angle of a cyclic quad is equals to the opposite interior angle. Or we can use the sum of opposite interior angles, which are supplementary. But with me, I see that I can use this angle and prove that it is equals to this angle, which is exterior angle of a cyclic quad is equals to the opposite interior angle. Once I prove that R2 is equals to P1, then I have proved that APTR is a cyclic quad. Now, I can start by saying angle P1 is equals to angle A5. I can start by saying angle P1 is equals to angle N. Why is that? This angle, it is made by this chord and the tangent. This angle, it is made by the chord and this tangent. So it means that it's going to be equals to this angle there. Therefore, our reason here, it is tan chord theorem. Reason, tan chord theorem, which angle P1 is equals to N. So this angle is equals to that angle there. Now, since we know that angle Q is equals to P2. We know from 8.1 TQ is parallel to PN. Why are we saying that? The reason for TQ to be parallel to PN, it is because angle Q is equals to angle P2. These are interior alternate angles. Therefore, it means that this is x there and this is x there. We know, right? Now, since these two sides are parallel, then it means that R2 is equal to angle N, because this is a N shape. There's your N shape. This angle is equals to this angle there. Therefore, angle R2 is equals to angle N risen interior alternate angles. Why are they alternating? Because TQ is parallel to PN. Therefore, angle P1 is equals to angle R2. Angle P1 is equals to angle R2 equals to A. Reason both equals to N. Therefore, A, P, T, R is a cyclic quadrilateral. Why is it a cyclic quadrilateral? It is because of, we give the reason why we're saying that. It is because of exterior angle of a cyclic quadrilateral is equals to the opposite interior angle. Exterior angle of a cyclic quadrilateral is equals to opposite interior angle. Therefore, this angle is equal to that angle, making an exterior angle of this cyclic quad to be equal to the opposite interior angle. Therefore, APTR is a cyclic quad, but not just a cyclic quad for these circles, as I've said it. Since we have proved that this is equals to that, then we know that there's an imaginary circle there of which APTR is a cyclic quad too. Thank you.